So please remember that all the things that I have discussed here in the video are also explained in text in a step-by-step manner in the handout, which explains how to perform all these operations. And now the next one is how to verify that your BioBrick has been assembled correctly. And we're going to do this using a new BioBrick. Okay, so for the new BioBrick, we're going to be using DNA sequences from a public repository. To do that, we simply have to go to the plus sign to create a new DNA sequence, and we are going to import it. There are several ways to import it. We could just have a local file, but what we're going to do is go to an external database, and it will be something as simple as coming to this text box and introducing the name of the sequence or an alphanumerical identifier. Now, how do we get this identifier? To do that, we can just come here and type parts.igem.org. So once we are within the iGEM parts catalog repository, we can simply go to the catalog section and then, for instance, go to frequently used parts. So this is just a selection of the most frequently used parts in the iGEM registry, and if you notice the first column on these tables, you can see this identifier, which you can just copy and then go back to Benchling, where you can simply fill this text box with a name and click search. And there you go, it identifies the right part, green fluorescent protein, from the iGEM repository. You can select here the project folder where to save it, and you can change the name here, something like GFP, open reading frame, and then the identifier. Click import, and the job is done. And you can see here the open reading frame that starts with a methionine. Go to the sequence map and see the whole translation. And see the stop codon and starts with a methionine. So the first open reading frame for my fusion protein that I have imported is the green fluorescent protein, as you have just seen. And in the iGEM repository you can see plenty of information about how it behaves. And also I have imported this FEP-A protein, which is a membrane protein because it's a transporter, and therefore that will localize GFP to the periphery of the bacterial cell. Now notice that these new sequences are the bare open reading frame. They start with the ATG, and we need now to introduce here the prefix and the suffix, because they only have the coding sequence. No enzymes that will be useful for us to do molecular cloning. So what we're going to do is to go to projects and then the share project. And here we will find both the BioBrick prefix and the suffix. So let's expand this so that we can click on both of them, prefix and suffix, and then let's copy them to our own folder. We are now back in our own folder, and we can open both of them. And we just simply select it all and then copy. In this tab you can now press Ctrl copy or Command copy, whichever works in your system. And then we will go to the beginning of the GFP and paste it. And to the beginning of the channel and paste it, using the usual hotkeys in your system. And then we do the same with the BioBrick suffix. We select it all, copy using the usual hotkeys, and then come to the end of the sequence of the GFP and the end of the sequence of the channel and paste it there. And if we look at the sequence map, we will see is that it contains all the enzymes for the BioBrick approach, both of them. And once you have that, it's very easy. You just need to proceed as with the previous assembly wizard to perform the ligation of these two fragments into the pCANA